Hello and welcome to my video, lesson 7.1 on the biological effects of radiation. Now when we talk about radiation in this context, we're actually talking about ionizing radiation. So this is a special type of radiation. It's not just EMR, electromagnetic radiation, that is light. We're talking about specifically radiation that is ionizing electrons out of an atomic structure. So when an electron is ripped away from an atom, that is ionized. That's an atom that has been ionized. So once it becomes, it doesn't have the proper number of electrons, is chemically reactive and reacts with other chemicals around it, and that's a problem. So this happens with DNA, which causes mutation and usually cancer. We saw this previously back when we talked about having a photon coming into an atom, and you bump up an electron up the orbital levels. But if you have enough energy, then the electron can actually get completely removed from an atom, and that's what's happening with gamma rays. Gamma rays are photons with a ton of energy, and so gamma rays are bumping those electrons completely out of the orbitals. Gamma rays are the weakest type of ionizing radiation, but because they are light photons, they can go and penetrate very deeply into a body or through material or whatever else. So if you're wanting to block gamma rays, you need to have thick lead in order to prevent the gamma rays from escaping. Beta radiation is high-speed electrons or positrons, which can be simply ripping electrons away by hitting them at high speed or using their charges to do so. So beta radiation is middle strength for ionization and also penetration. They have larger wavelength due to them having bigger particle, basically. De Broglie's wavelength, basically it's an electron moving really quickly, or positron, which is the opposite of an electron, just a positive version of an electron. And then alpha particles can also rip away electrons from an atom because they're so positively charged they can soak up the electrons to make proper helium instead of just a positive helium nucleus, which is an alpha particle. So they don't penetrate very far because they're very big particles. I mean, relatively speaking, they're still atoms, but they're atoms, not electrons. They're way bigger than beta radiation, or photons are even smaller. So because these are really big particles, relatively speaking, they don't penetrate very far, but they have room for 2 electrons per alpha particle, and they want to rip those electrons out. So they do they're really strong at it. So a thin piece of paper can stop alpha particles because it's like shooting a ball at a wall. It just doesn't get through. But yeah, that's basically the idea of alpha particles. So to protect yourself, you can decrease the exposure time to a radioactive source, increase the distance to the source, or provide shielding, which at best case is lead. Interesting that our bodies really want to absorb a type of radioactive iodine, which is has a half-life of a couple days. And so this radioactive iodine gets absorbed by our thyroid gland. So what we do is we take iodine pills in order to oversaturate that thyroid gland. And so the thyroid gland can no longer absorb any more iodine, and therefore doesn't absorb the radioactive type of iodine. It's kind of like a vaccine, but for radiation. It doesn't work for all radiation. It's just the common radioactive iodine that it is preventing. But it is a big deal when we're talking about nuclear fallout, basically from nuclear explosions or nuclear meltdowns. We talk about the need for iodine pills. So in 2012, was it? We had the nuclear meltdown in Japan, and that reactor, basically, when it melted down, I remember being in high school, and they talked about, oh, do we need to have iodine pills here in North America. We never ended up using it, or at least I never did. Maybe on the coast, maybe some people did, but in Japan, a lot of people did. They would have used iodine pills around that time for a couple days, like 2 weeks sort of thing. And then the iodine source, the radioactive iodine, would have dissipated. The half-life would have basically gotten rid of all of it. So here's kind of just a nice summary of the dangers of radiation. So we've got different types here, alpha, beta, gamma, and the different penetration strengths, and their ionization strength as well. We use different ones for different technologies. So smoke detectors use alpha radiation. Beta radiation can be used as a tracer in your body, and gamma radiation, we use a gamma knife in order to try to destroy cancer cells, and that's a pretty cool technology. Or sterilizing things in general. Because shooting gamma rays at something doesn't make that thing radioactive. It's the radioactive particles that are a problem. There's a difference between the source and the radiation itself. So the radiation is bad, that's what's going to hurt you, but the source is what's causing the radiation to exist. So if you have a source near you for a few seconds, that's a problem, but if you have it next to you for like 3 days, that's a bigger problem. So speaking of, how could you prevent yourself from being harmed by a gamma radiation source? Well, really, there's a few options, but lead shielding, distance, and decreased time. So decrease exposure, increase distance, and provide lead shielding. Alright, so there's another 2 questions here. I recommend you pause the video now and see if you can solve the other 2. Alright, so example 2, it says, if we're worried about alpha particle radiation and there's radioactive dust all around you, how can you prevent bodily harm? Well, you wear some sort of suit that protects your skin. It doesn't have to be a thick suit, but it has to be something that just prevents the dust from settling on your skin. And most importantly, some sort of mask, breathing apparatus that basically filters out the dust. Because if that dust gets into your lungs, that's what's really bad. And then it's actually worse than any other type, because now it's inside your body, radiating your body from the inside. Okay, and example number 3. If you had a beta source, what can you do to prevent radiation damage to your cells? Well, I mean, you can do basically all the same things as we did previously. So some shielding of some sort, increase the distance, and decrease the time. It's the same as before. But the shielding doesn't need to be not super strong. Okay, but some sort of shielding would be good. So those are all the things you can do. All right, I hope this helped you better understand the idea of biological effects of radiation, and good luck.